For 1 through 4.3 review, is this graph a function? That's the first question. It passes the vertical line test, so we would say absolutely yes, it's a function. Is its inverse a function? That means, does it pass the horizontal line test? And it does not, so we're going to say no to that. And then, is it 1 to 1? Well, 1 to 1 means you said yes twice, so since we did not, this is not a 1 to 1 function. Whereas if you look at B, is the graph a function? Yes. Does it pass the horizontal line test? Yes. So is that 1 to 1? Yes. It is a 1 to 1 function there. Okay, so on this one here, what we're going to do is we're going to graph the inverse, but I'm going to do it by plotting ordered pairs. Remember that this is the ordered pair right here, 1, 2. So that's going to turn into 2, 1. And I'm going to put a dot right there. That's where that one would turn into. Okay? This is the ordered pair, 1, 2. 1, 2, 3, 4, 5, 6. So be careful here when we do this. This does not turn into any negatives. It's just 2, 6. So we flip them. So it's going to become 1, 2, 3, 4, 5, 6, 2. Okay, so I've got that point. I've got this point. And then what about this one? Negative 3, negative 1 becomes negative 1, negative 3. All right? Oh, I went a little bit too far there, sorry. Negative 1, 1, 2, 3, which would be right there. And the one thing I noticed right there is that when I put this point down here, it didn't look like a reflection over this line. So I knew I kind of journeyed too far down there. We should always have a reflection over this line, y equals x. That's that line right there. Okay? All right, so when we do this next one, we are going to, think to ourselves, where's the reflection point? But it is just flipping the order pair. So 1, 2, 3, 4. Negative 4, 1, 2, 3, 4, 5, 6, negative 6. So that would be 1, 2, 3, 4, 5, negative 6, 1, 2, 3, 4, and it is right here. Okay? That's just those 4 ordered pairs. That's all we did. But if we connect them, we should be able to get the sketch of the inverse. That's very hard to make straight segments on this pad. I'm sorry, but that's the idea. Okay? So now on the next one here, how do we verify that functions were inverses of each other? Well, I'm going to do that work right up here, and we got to show 2 things. We got to show, f of g of x is actually equal to x. So let's do that first. So taking this function g of x and putting it into the other one looks like this. 4 minus 3, and then what do? We put into that one negative 1/3 x plus 4/3. And then when we do our work here, when we distribute the negative 3 through, this is going to be equal to 4 plus x. That's what happens right here. And then when we distribute it through, that'll say minus 4. Well, this is equivalent to x, and that's exactly what we're showing. If we can show this 2 times, we're good. All right, so that's the one-way composite. Now we do the other way, g of f of x. Okay, so g of f of x, let's do this one. Well, now I have negative 1/3 x. So now I'm going to go to my another color here, maybe red, and be like, okay, so now I got to put in 4 minus 3x there. And then I have to go back to blue, still add 4/3. So it's showing the 2 different ways, and then when we distribute through, what happens? Well, this is going to become negative 4/3 plus x plus 4/3. And those cancel off, so we get x. So once I have this work and this proof shown, I have verified that they're inverses of each other, because that's the test for verifying that. Okay, so now there's a lot here in these next 3 problems. All right, so these are the ones where we're maybe a little bit more tricky for us, but the first step of the problem, and I'll do this one in red, is to, just like we did on the graph, switch the x and the y values. So that now says x equals 2y plus 1 over 5. Okay, every problem's a little bit different, but it is a 2-step procedure. 1, switch the x and the y. 2, solve for y. So now I'm going to solve by multiplying both sides by 5. So now I'm sitting here at 5x equals just 2y plus 1. So this one's not too bad. In fact, I'm going to do a two-step procedure here and show you how I'm going to finish here. That would be y all by itself if I subtract 1 and then divide by 2. So this is going to be 5x minus 1 over 2. So this right here is the inverse. So if I'm going to write out my final answer here on my test, I'm going to put it in inverse notation. Okay? The inverse is equal to 5x minus 1 over 2. And then I'm going to color code these last two parts. To find my domain, I'm going to look right up here. I'm going to look at the original function. I'm going to look for square roots. I'm going to look for fractions. But really, there are no issues with my domain up there. All real numbers will work. So the domain of the function is negative infinity to infinity. All right. So now let me grab green here. And we have to do our range. Well, the range of the function is the domain of the inverse. So now I look back up here to this one, and again, no issues. So because of that one, I would have my range as negative infinity to infinity. Okay? Now, for B, let's jump to that one and kind of look what that would look like. I'll start with black here. So the first thing we would do is make x equal to y plus 4 quantity squared. Well, and then instead of expanding this binomial, we're going to take the square root of both sides. And that's going to lead us to root x equal to y plus 4. Not plus or minus root x because we're dealing with a one-to-one function. So root x. And then we're going to do one more step and subtract 4 from both sides. Okay? So that would be y equal to, we would have root x minus 4. All right? So if I'm writing my final answer, I'm going to say the inverse function is equal to root x minus 4. Okay? Back to domain now. Okay, go to blue again. The domain of this function comes from the original problem. Now here's the great part, and I glossed over this at the beginning. They gave us the domain. This right here, this is a parabola. That is not a one-to-one function unless we limit its domain. If we limit its domain, what we're really doing is just looking at part of the graph, which is a one-to-one function. So this right here is the domain. They hand it to you. They say, hey, here's your domain. Okay, thank you. And then the range. Well, the range comes from, again, the domain of the inverse. So there is no fraction here to worry about, but there is a radical. So what's the radical issue? Well, hopefully we know by now, and we're getting this down, that radicals have to be 0 or positive. So 0 to infinity would be the range for that one. Okay, now the last problem here on this page. Let me do this in red, or sorry, in black. So now maybe a little bit more complicated because we have to deal with a couple y values here. So this is going to be 2y minus 3 all over y plus 4. Okay, what are the instincts here? Well, my instincts are to multiply both sides by y plus 4. And that is going to do some nice work on the right side. That's going to make it just 2y minus 3 here. Well, if I multiply this side by y plus 4, okay, my instincts might be to distribute, and those are good instincts. So in this one, xy plus 4x. Okay, so now what's the issue? Well, the issue is I have a y on both sides. And to truly solve for y, I got to get all the y's to one side. So I'm running out of space here, but I'm going to do something here. I'm going to add 3. I'm going to do two things at once. I'm going to add 3 to both sides. So now that side would say 4x plus 3. Do we see that? If I add 3. But I'm also going to subtract xy. So now it says 2y minus xy. This is not the only way to go about the problem, but it is probably the way most of you would pick. All right, so we got this here, and then we got to remember that fancy maneuver. What's that fancy maneuver? Well, keep the 4x plus 3 there. It's totally fine. But the goal is to get y by itself. And since those aren't like terms, I can't put them together. So what's going to factor in here? Oh, factor. Okay, so take a y out, and on the inside, we would have 2 minus x. And then now I want to divide both sides by 2 minus x to get that y by itself. Okay? So again, if I'm taking my test here, what are they going to ask for? They're going to ask for the inverse. So I'm going to put it in inverse notation. The inverse function of x is equivalent to 4x plus 3 all over 2 minus x. Now remember, if you did this problem a little different way back here, you might have the same answer just looking differently. The way to know is to look and see if every sign is opposite. Like if this says negative 3, negative 4x, negative 2, positive x, then that's the same answer. You're good. And you should get the same domain and range either way. So here's the deal with domain. Okay, domain, I'm supposed to look again back at the original function. Well, that's back here. And we know we cannot have negative 4. So negative infinity to negative 4 union negative 4 to infinity. Okay, that's our domain. And then switching to green here, we've been talking about range in green. The range of the function, the range of this is actually found by looking at the domain of the inverse. So we can't have 2 there. So negative infinity to 2 union 2 to infinity. All right? Okay, I'm going to cut that off at this page right now. Stay tuned for more videos.